We have these priests of the modern world. Who are they? They are the mathematicians, the mathematical physicists. They're mathematicians who call themselves physicists, talked about in the last couple of weeks. And what do they do? Well, they do the same thing that the priests of old used to do. You know, what do they do? Well, they were the only ones who knew how to read or write in the little towns and the villages. And so they had their church, their Sunday schools, whatever. People went there, and the priest would tell them what to believe. And he was the only guy who knew how to read. He read the Bible. Maybe he went to some school of some kind. And so people believed him because he's the only guy who really opened the Bible and read it. All the other people would just listen to what he had to say. And the guy could tell him anything he wanted. In fact, he did. And he usually gave his personal opinion on how people should behave, what they should do in society, what you're not supposed to do, what is sin, what is virtue, etc. He would lay it out on the line, and a lot of it had to do with his own opinion, his personal opinion. And that sounds a lot like what the mathematicians are doing today. So here you have, these are the some pictures of how it used to be. The priests, this is like from the 13th century, these paintings they had at the time. You can see that in all ages. Here you have in the maybe 16th, 17th, 18th century, must have looked something like that, okay? And that lasted even to the 19th and even 20th century, when you had these people talking from the pulpit and telling everybody what they had to believe and what was good, what was wrong, what was right, these kinds of things. People would listen to them. So these people were the preachers. Now, when you get to the 19th century, you get a lot of people who, they could read the Bible on their own. In fact, that's why, some religions got started, new religion branches, because people said, hey, I don't believe like that guy. I believe in something else. And the Bible here says something different than what this guy interpreted. So that's when they started branching out into all these different religions. But the point here is that, at least for many centuries before that, people simply believed the priest because he was the only guy who was educated to some degree. And so whatever he said, it was law, more or less, And we have that same situation today with these mathematical physicists because they're the only ones who can read the hieroglyphics, the symbols, mathematical symbols. And people have this idea that those mathematical symbols can tell them something about how the universe works. And can it describe? Yeah, it can describe. A lot of the equations can describe many things about our universe, about, motion, about how things move, how much they weigh, how much time they take. That stuff is not an issue. What's an issue is the interpretation of those equations. That's the question there is whether first a mathematical physicist has any special insight. Does he have any authority to interpret that for you? That he can describe? Yeah. Can he explain? Can he use the equation to explain? Can he translate the description into an explanation? That's what's at issue. And yeah, so today what you have is these fellows. You have, here's one fellow, his name is Sean Carroll. He's at the Royal Institution there, talking some stuff that he wants, and what you will see in all of these cases is that they don't use equations. They don't talk about equations. They don't analyze equations. What they're giving everyone here in the room is a physical interpretation of the equation. They're giving their opinion of how the universe works, why it works the way it does, the causes, okay? And here you have another fellow. His name is Neil Tyson. And he's also telling the crowds, what to believe. And what is it? They talk about, the physical interpretations to equations, not the equations themselves. They don't even talk about experiments. You can see there's no lab there in the theater, right? So the issue is that these people are giving physical interpretation. They're interpreting the equations for the crowds. And here's a couple more. You've got Roger Penrose and Michio Kaku and Hossenfelder there, and what they do is they talk all day long about physical interpretations. They talk about explanations and not about descriptions. It's what they get the explanation from their interpretation of the equations. That's what's happening. And the question is, do they have any authority? Do they have any right, any expertise in interpreting, how the universe works? And in the old days, they used to have this, when you question the priest. I didn't understand that, priest. What do you mean he sends angels to do this, and the spirits appear and so on? And the priest would tell him, hey, God works in mysterious ways. Okay, so you had to say, oh, okay, God works in, I don't understand the ways of God. But if you did, you were arrogant. How could you possibly understand the ways of God? Do you think you're God? Do you think you're an angel? Do you think you're sitting there next to God, that you can interpret what God has done or is doing in the universe? But it turns out the priest, he did assume that role, and he says, I know what God wants. And he would give you his opinion, say, and I know because I read the Bible and I interpreted the Bible. And so you find these passages there, for my thoughts are not your thoughts, neither are your ways my ways, saith the Lord. Okay? Yeah, he works in mysterious ways. You don't understand the ways of God. And that's what they would answer when, they couldn't answer the question. They say, well, God works in mysterious ways. And that's all the problem. Okay? And you had, for we walk by faith, not by sight. Okay? You don't have to see and touch and verify. We do it through faith. Okay? You got to move your hands in the air and believe through faith. Okay? And nothing has changed, really. These people work on faith also. Here you have good old Tyson. What does he tell the crowds? Does he tell them, first he says, believe in me. Let me interpret how the universe works. According to our equations, I'm going to translate that into an explanation for you so that you get an idea of how this universe works. And you say, well, I didn't understand that. What do you mean a particle can be at two places at once? What do you mean that gravity is the warping of time? What does that mean? Or that the earth drags time around? I don't understand that quite well. What are you referring to? Well, he doesn't say God works in mysterious ways. They say it differently these days. And let him say it for himself. He says the universe has no obligation to make you understand, to give you a notion the way you think the universe should work. Okay, so here it is. Listen to him.
The universe is under no obligation to make sense to us. It's the observations that matter, even if they conflict what feels right to you.
Okay, so the universe has no obligation to be like what you want it to be. That's the answer. It's the same thing as before, was God works in mysterious ways. Essentially, that was it. And so there's no difference in what we have today than what we had in those days. And of course, we have all these celebrities. I've shown them a couple times now. All these people, some of them are dead, but all these people spread the word. And what do they talk about? What is it that we don't understand? I mean, maybe there's something that we don't understand that we should be able to understand if we learn some math or whatever. Is that the issue? Will math solve the problem? If you go to the university and study math for 10 years, are you going to have any greater insight into how this universe works? The causes, the mechanisms? Or are you going to be like all these people? And here, let me show you some examples. These are the first ones are from quantum mechanics. And here you have, what these people believe in or how these people explain certain things, saying that it's been proven by quantum mechanics because otherwise your computer wouldn't work, et cetera, et cetera, et cetera. And these are the explanations they give you. Here's one, okay? This is from the Wikipedia, and someone put it up there, and it's saying quantum mechanics and atom can be at two places at once or have two states. In other words, it could be vibrating and not vibrating at the same time. Essentially, they're saying that two particles can occupy the same space, right? Because if one is vibrating, the other one's not, you're talking about two different particles. But they make it as though the particle has two states at once in the same location at the same time. And that's irrational, okay? But what this does help you understand is why objects go through objects. Because if two particles, as they measured, improved, and whatever in the lab, have two states, can be at the same place at the same time with two different states, you're talking about two particles, and that means the two particles can coexist, what is called superposition, okay? They can exist at the same place at the same time. And that's good for my theory that says that objects go through objects, and you cannot avoid that in any theory. I don't care what theory you have, objects go through objects in your theory. You just never thought about it, never popped into your mind that objects go through objects. So when people say, Bill, your rope goes through the rope, right? Yeah, rope goes through the rope, okay? It crosses it and goes out the other end, and neither one of them gets cut. They just go through like a ghost going through a wall, okay? You say, but that's irrational. All theories then are irrational because every theory ever invented by man has objects going through objects, yours too. So anyone who says that he doesn't have objects going through objects in their theory, hey, just bring it on. I'll be glad to tear it to pieces. I'll show you that objects go through objects in your theory. Okay, and here you also have, aside from that, you have also contradictions because you have in quantum mechanics, you have special relativity says the speed of light is the maximum speed limit of the universe, etc., etc. And then you have these people who invented tachyons, and they say, well, it goes faster than light. Why did they have to invent the tachyon? Because some things they could not answer. And they say, well, we can explain it if we have something going faster than light. And then they came up, well, what are these? Well, they're known as tachyons, and they come from the future. And they come with all this nonsense explanations. And again, the priest is telling you to believe it because that's what the equations tell them, okay? So the fact that the equations tell them that does the question that you should ask yourself, does that translate into explanations? Do descriptions, mathematical descriptions, translate into explanations? Okay, and here you have another thing from the quantum world. Okay, we have the proton and the electron. And the electron supposedly is somewhere around the proton. Okay, somewhere around. It doesn't go in an orbit anymore. They say just here and there, but we're just going to use the standard one, the one that everybody believes in and the one everybody illustrates out there, which is the electron going around the proton. And the question is, why doesn't the electron fall and spiral into the proton, into the nucleus? One is positive, the other one's negative. You would think it would go all the way. In fact, that was the issue that started quantum mechanics. They tried to answer that question. That was the question you were trying to answer. They never answered it. They never explained why the electron doesn't fall to the nucleus. And all that Niels Bohr did in 1911 was say that there are all these orbitals, these energy levels, and he figured out that it's either here or there. But he never explained why it doesn't go all the way down to the proton. He just described and said it's always here or there. And with that, he could explain, the certain things. And then the one at the bottom is, why doesn't the electron fly away? Why doesn't it, fly out of the atom? And again, they have no explanations for either one. And so this is irrational because they have an irrational atom. They cannot explain that atom. They cannot explain why the electron beam doesn't fall or doesn't fly away. Neither one. And to this day. They have something called virtual particles. Now you talk about irrationality. Here you have magic. These particles just come in and out of the void. They borrow energy, as they call them, whatever that is. They borrow energy for a split second so quickly that they cannot measure them. Here you see these particles among, the particles that we have, normal particles in our everyday world, atoms and so on. And these particles come in and out of existence every 2 seconds. And the question is, when they come in, do they leave a hole behind in space or what? I mean, are these particles the ones that make up space? And that's when they start talking about energy. And they say, well, they borrow energy and they come in as a particle, then they go back and release the energy. So they're talking about math. They're not talking about a physical interpretation. The physical interpretation is absolute bunk. It's nonsense. It's no physical interpretation at all. This is how they illustrate the particle, these virtual particles, whatever that is. They say, well, these are the virtual particles. They come in and out of existence every gazillionth of a second, and they can't measure them because they're too quickly coming in and out. So there's no way to put a detector or anything to detect them. And what's really happening is they are missing some numbers, some values in their equations. And they say, well, we have this, and that. And what's missing is this little piece that we can't account for, and that's what they call a virtual particle. They just put it in by hand and makes the equation come out right. And they say that's the energy we needed, or the charge that we needed. So they have these virtual particles come in, fill in the hole, and go back. It's like dark matter, essentially, or dark energy. They needed to fill a hole in their equation. And so they created this dark matter thingy, saying there's this mass that we can't account for, and they just put it in the equation and say, when we put this in, we can make all the stars work the way they're supposed to. No kidding. Yeah, that's a fudge factor. It's called, just ad hoc, put in by hand. Okay, here's another one, a terrible one, which is the wave function collapse. Never have that happen to you. You have a wave and it turns into a particle upon seeing it or touching it. Totally irrational nonsense. And here it is. Here you have the wave before measurement, and then when you measure, it turns into a particle. How do you like that? Okay. So how did that extended wave, which is a bunch of vectors, right? That's all those are, moving vectors, very dangerous, very scary stuff. And suddenly it collapses and turns into a particle that can be measured. So suddenly what could not be measured because it was traveling as a wave suddenly collapses, turns into a particle. It's called the wave function collapse. And what is a function? Well, it's a number. It's an equation. It's got to do with math. It's got nothing at all to do with physics. Okay, here we have another little bit of magic from quantum magic, they call it, in fact. And it's the entanglement. You have a particle one side of the universe that's going clockwise. At the other end, whatever particle you measure is going counterclockwise. And when you switch one to counterclockwise, the other one goes now clockwise. That's what they say is happening. And here you have a comparison to how we see that. Okay, let me get this one out of the way. And what you see is there the rope model. Yeah, with a rope you can explain it, very easily. If you, little worm that I've got here, if you, from my end, it's going counterclockwise, hopefully from your end. Let's see there. From your end, it's going clockwise, okay? Now I'm going to turn it around. Mine is going clockwise. Hopefully from your end, it's going counterclockwise. Yeah, and so that's one issue. The other issue is they do it without a mediator. They call it action at a distance, which is the scientific version of black magic and witchcraft. Action at a distance, remote control. So they make, it's like pinching dolls, the voodoo dolls. You pinch them and it hurts you. Yeah, sure. That's what they're doing when they talk about action at a distance. And they've got all kinds of actions at a distance in quantum mechanics and general relativity, for that matter. And then obviously you have this fellow I've been talking about lately. His name is Arvin Ash, and he tells us that they have all these fields out there. Every particle, every type of particle has a field. And the question is whether all these fields, are coexisting in the same space. Do they go through each other? When a particle moves, right, does the field move with it, and go through another field? You have the graviton field and the muon field and the pion field. You got all these different fields. Do they go right through each other? Which is what people criticize about the rope model, the fact that ropes go through each other. Well, do fields go through each other? Do energies go through each other? And here you have it from the horse's mouth. Here is good old Arvin Ash. He's going to tell it to you in his own words.
All these fields extend out
in all of space-time. In other words, the fields are always there and exist everywhere, including inside your body. Now, although they exist everywhere and you can't see them, they are not nothing. They are teeming with virtual particles. These are particle-antiparticle pairs that get created and destroyed. They come in and out of existence constantly. These virtual particles can't be measured, but nature allows the creation of these virtual particles by letting them borrow energy from the vacuum.
Now, how's that for a scientific explanation? Does that make any sense, what he said? Any of it? All of it is garbage. All of it is nonsense, poppycock. I mean, none of it survives rationality. None of it survives science. But they're saying, hey, they're the priests. They're the ones who studied math, warmed the seat for 10 years at a university, so they have a right to tell you. Well, they can have a right to tell us the equation and even what they measured. You know, as far as we're concerned, they can tell us what they measured and what the equation is. No problem there. But for them to interpret that there are such things as fields out there, which are just a bunch of numbers, that there's a lot of energy, which is a mathematical concept, that there's a mass, a charge, you know, all those words, time, you know, force, all those are words that have to do with math. They have nothing to do with physics. In physics, we need physical objects. You have to talk with objects. You have to give your physical interpretation with objects. You can say, you know, the rock broke the window. That's a physical interpretation. Very simple. But you can't say the mass went through so much energy or such force that it broke the window. You know, that wouldn't stand in any court of law. A judge would throw it out. You can't talk like that in rational world. You know, that's okay in math, not in a rational world. You have to explain with objects. Okay, here we have another fancy thing that they've invented in quantum mechanics. Is this rational, what they're saying here? They're showing the gluons, right, as bed springs, and they have, what the gluons do is they keep the quarks together. And that's how they illustrate them, okay? So we have these gluon bed springs, and they illustrate it like that, you know? So, I mean, what do you think those bed springs are? That doesn't look like a particle to me, okay? So, and in fact, they had to explain why the quarks don't fly away, and they had to put something that connected the quarks to each other. So this mechanism that they have is ad hoc. They had to put something in there, you know, it's invented. You know, it's got nothing to do with reality, even if any of this survives reality, you know, the quarks or the you know, that 3 quarks make up an atom, which is obviously nonsense. But the fact that they're held together by these bed springs is irrational. And one of the reasons you can prove to yourself that it's irrational, you can be totally safe in concluding that, is that you don't find these bed springs here where you're supposed to find them in the standard model of particle physics. Where are the bed springs? You know, here they show the gluons and so on, but they don't show them as bed springs. You know, there you have the letter G. Is that a gluon? A letter G, a ball with a letter G on it? Could have put the 8 ball. I mean, you know, black one with an 8. You know, how come they don't put a bed spring there? Why do they show a particle if you cannot pull with a particle? If gluon is a particle and we have all these gluons going between quarks, how does one quark pull another quark? Because that's what they're trying to show there, that the quarks remain friendly to each other because they have these gluons maintaining the pull between quarks. Well, you can't do that with particles. If they're throwing particles, you can't pull. So they had to put the the gluon bed spring to explain the mechanism, and then when you come here, they show you a little ball for the gluon. Yeah, sure. You know, and that's how they cheat. That's cheating because, you know, it means that they don't understand. And again, they say, well, God works in mysterious ways. Or no, they say it differently, right? It's not God works in mysterious ways. It's the universe doesn't have to agree with you. That's how they say it. So they become interpreters for God. You know, like they have a special ear to God, the Father Universe and Mother Nature. And they can tell you they're the representative. They're the angels that God sent to earth, you know, these mathematicians. And they're going to tell you how the universe works. And you got to believe them because they know all the math, all the symbols, all these secret codes that allow them to communicate with Father Universe and Mother Nature, and so, with a natural philosophy or whatever. And so they have a direct line to God, and you better believe them. And when you say, well, you didn't understand, I didn't understand that. Well, they don't say, God works in mysterious ways, not anymore, because people would shy away from that, especially in the scientific world, what is called the scientific world. No, they say that the universe doesn't have to speak your language. That's the way they put it today. And here's the gluon and quark soup. Okay, you can see the gluons crashing against each other together with the atoms, and all these gluons and quarks, they just go out. And what you see there is the star, this strange looking thing here, right? And what they're showing there is itineraries of the particles. That's what they're saying that they took a picture of or imaged in some way, right? With computer images of what they think is happening. They say there was a collision in the center at ground zero, and all those lines that you see coming out of ground zero, all those lines are itineraries of particles, okay? Sounds like they're describing really the rope model of the atom. That's what it really sounds like. Okay, there's the rope model of the atom right there. Okay. Anyways, then they have all these other things that, like the gluon springs. They have the orbitals. I've never seen an orbital. They just put that in by hand. We don't know what it is because they have all these orbitals merging and doing things. They treat them like physical objects, and an orbital is just a bunch of orbits of a little bead. That's what it is. It's where you can find the electron bead. That's what an orbital really is. And like that, they have these bonds, which they also bring out of nowhere because you won't find them in the standard model. And here you have, I call them James bonds, because they're very mysterious, right? And the atom is mostly molecules. The atom and most molecules are held together by strong attractive forces. Forces? What do you mean forces? It's held by forces. I mean, you can say it's held by strings. You can say it's held by wires, some elongated object, I don't know, a fiber, a hair. But to say that it's held by attractive forces, what forces? What is a force? That's a mathematical concept. And they call them bonds, chemical bonds. So now the force has become a bond. Bond is a thing, right? You're insinuating that there's a thing, some elongated thing that's holding these atoms together, right? But then they call them forces. So they're not dealing with a physical interpretation. They're talking about math, and they're introducing their mathematical jargon into a physical interpretation. That's what they're doing. And yeah, that's why I call them James bonds. And these bonds are formed through what? The interaction. So it's like an emergent property of some kind of valence electrons of the combining atoms. Okay, so what's the issue? They're talking about interactions, but they're not telling us in their jargon, in their language, they're not telling us what physical object is doing the mediation. That's the problem. Okay, they just call them bonds. So what is a bond? Why isn't it in the standard model? I mean, if it's a stick, put it in the standard model and just call it, this is a bond, so we know what we're talking about, right? No, they don't put the bond. They put the bond by hand in the standard model. They put it in by hand in their physical interpretations out of nowhere, ad hoc. And that's the problem with all this. You don't get ever a physical interpretation. And of course, people say, well, I didn't understand. Well, God does not have to agree with you. He talks a different language. We don't know the mind of God. They don't say it like that. They say, the universe does not have to agree with you. Okay, and here you have one fellow, and his name is Roger Penrose, and he's also contributed a lot to quantum mechanics, the science, right? This is what he contributed. The Penrose staircase, and especially the one at the bottom, the wave packet. That's his wave packet. That's what he drew in his book, one of his books. Okay, I got that out of his book. So there you see it. An arrow going right through a bed spring, I guess. That's his whole contribution that he ever made to science, aside from the naked singularity, right? which was prohibited because it violated sex rules, naked singularity. Okay, so what's wrong with all these people? Well, the issue there is that they screwed up when people like Fresnel and Maxwell, when they came out and they invented this thing called the transverse wave. Okay, and so this is what they came up with. They invented this transverse wave, which is a mathematical concept, and we're replacing that with a physical object which has the appearance of a rope. So we're saying that's what they mistook all these years. They mistook a rope for this wave, transverse wave thingy that they have. And the issue there is that, because of that, they have this wave moving. And what you're staring at, all those arrows, they're, they're vectors, and they're moving. The vectors are moving. What's a vector? It's magnitude and direction. So what we came out, at least at the beginning of the 20th century, is that these waves come out of the atom, and it comes out when the electron goes back and forth between orbitals or energy levels. So when the electron falls or rises, it creates these waves, these transverse waves, which are just a bunch of vectors, right? And that's the energy that comes out of an atom. And apparently this energy is unlimited, because the atom can produce all this energy out of nowhere. So that's so strange, because, it just creates this energy that comes out of the atoms. And, it's forever. They can do it forever. So yeah, the mechanism or the explanation they give for all this is totally irrational. It has no place in science. And again, they say, well, you have to believe us because we measured and we have the equations and we speak for God. We're the angels that God sent, the mathematicians. Okay, so what does this look like? Well, when you compare them, you can see the difference in the case of quantum. They have this atom. The electron is moving back and forth between energy levels, and it creates this wave that goes in one direction only. It's just a bunch of numbers, and it's inexhaustible. The atom can throw all this energy outwards forever. Whereas we say that, there's no such thing leaving the atom. What you have is a rope-like extended entity, very thin, right? Extremely thin, unimaginably thin rope-like entity, DNA-like entity that binds any two atoms. And when the atoms expand and contract, what they do is torque the rope. And there you can see comparison between their model and the model that we propose here. Of course, their model was probably coached by God, okay? And our model is coached by someone else, the devil. Okay, so so if you always wondered where this came from, I got my my ideas from praying to a different kind of God, the God of evil. Okay, so that's quantum. Okay, how about general relativity and special relativity? Well, before we can get to that, let me just finish up here. We can include gravity, something that quantum doesn't have, okay? And here you can see that if every atom is connected to all others, like we say here, you can see why, you can explain the acceleration of gravity, the gravitational acceleration. As an object approaches the Earth, the ropes that connect every atom from one object to the other, they fan out. And that explains why things accelerate as they approach another object, gravitationally. And for those of you who question that, well, here you have our good old friend Richard Muller, and he tells us that every atom on Earth is pulling on every atom of you, and you're also pulling on it. So he's explaining to you, or he's justifying to you, that what I just said is correct, that it matches what they've already shown, and that is that all atoms in the universe pull on all others, meaning that all objects had better be physically interconnected. And if you doubt good old Richard Muller there, well, here you have other testimonies, you could say. Okay, here they are. Okay, gravity is a pull force. That's from the AI, right? There you have some others. It's a non-contact force, which again, if it's non-contact, you're doing black magic. So you can't say it's a non-contact force. It is a contact force. It's a force, whatever that is, that we cannot see or touch, meaning it's a physical object that interconnects any two atoms. We just can't see or touch it. That's the only assumption we had to make all these thousands of years. And there you have more, elements of geodesy. These people say gravity is a pull force. They're all saying it's a pull force. There is no push force for gravity. Those people who believe in push gravity, well, good luck with that. No, gravity is a pull force. It's more or less just in case, like magnetism. Here you have magnetism, right? My two little refrigerator magnets, right? Those there, okay? And they attract, right? Okay, so there's something here. In fact, you can feel that nothing's pushing on my hands. I feel the pull from the inside. But if you have doubts, we have another magnet here, right? And it's the opposite magnet. I'll do it with the yellow one, I think it is. And I know this one also sticks, but look what happens when I put the red against the blue. Okay, I try to put them together, and they push each other away. They don't like each other. They're the same pole, whatever it is, whether south or north or positive, negative, doesn't matter, but they have the same pole. So that means, again, the push is from within. It's from inside the magnet. You can see how they're pushing outwards, and you can test this yourself just by getting two magnets, okay? So here they attract, okay? Here they attract, meaning something's here that's pulling them together, and when I switch them around and have two of the same pole, again, it's within. The push is from within outwards. So we have to explain what's in there. And here's another trick that you should see, and it's this, that, here these two magnets are pushing each other away, right? And I'm going to do a magic trick you never saw in your life. I'm going to put my finger right through that object that's in there, in between there. And you can see I'm going right through it. Whatever's there, I'm going right through it. So yeah, matter does go through matter, because there's matter in there, matter we can't see or touch. Some exotic type of matter that cannot be seen or touched. I'm going right through it. And I'm not interrupting the magnetic properties at all by putting my finger through it, okay? In other words, the whatever's there, I'm going right through it. Whatever's keeping these two magnets apart or pulling them together, I'm going right through it. I can put my hand right through it and won't see or touch it. So yeah, matter does go through matter, especially the exotic matter that Mother Nature uses. So for those people who have doubts about objects going through objects, yeah, all theories have objects going through objects, not only with magnetism, but also with gravity, light, etc. Okay, here we have, again, general relativity, and what do they have? Well, what do they propose? Again, these are the explanations they give you. Then they say, well, no, go to philosophy and they'll explain it to you better, but this is what they give you. And these are the people who studied math, right? And they say, look, we studied all this math. We can tell you exactly how this universe works. And here it is, okay? They show you this. They say, look, we have space and time, okay? And you look at and what does that look like? Well, it looks like some kind of fishnet of some kind, or maybe, a mat. Okay, maybe, I don't know what comes to your mind, but that's more or less what that looks like. And yeah, it looks like a physical object. It's got shape. Okay, so it looks like I'm looking at a physical object, and they are going to use this to give you a physical interpretation. This is not math, what you're staring at. What you're seeing is a physical object, if they're going to explain gravity with this, right? But what's the next thing they do? Well, they mathematize it. They say, oh, but we were talking about numbers. See, all those things are just numbers. Oh, they were numbers? Yeah, and here, in fact, let's get rid of all the extra stuff that we don't need in there, and here you'll see it. It's numbers. That's what we were staring at. We were looking at numbers, number lines. That's what they're known as. Okay, so time is a number line. It's not a thing. It's not a physical entity. But see, they're going to use this thing, and they're going to say, look, here, let me explain gravity to you. And this is what gravity is. The warping of time. They're bending the number lines. That's what they did. And so, yeah, we have a problem with this because what they did is turn a mathematical concept into a physical object to get away with a physical interpretation. Okay, so this is absolute nonsense. Okay, so the issue is you cannot use this as a physical interpretation. And of course, when you say, well, I didn't understand that very well, what do you mean you bent the number line? You bent time, and that's gravity. Well, yeah, go to the philosopher, or, the Father Universe doesn't speak our language, whatever nonsense, doesn't have to, Father Universe or Mother Nature, they don't have to conform to your ideas, okay? And here we have another one. These are the gravity waves that supposedly they measured, coming from the collision, or not collision, really the blending of two black holes. I don't know why they didn't collide, because if you have one black hole close to another black hole, you would think that, they would smash into each other because they have such outrageous gravity, outrageous mass. So the gravity must be beyond imagination. They should just bump against each other, and they have them instead rolling around. You can see them here. See how the two black holes are rolling around each other, and by doing so they create all these gravitational waves in space-time. And I'm wondering if all those gravitational waves are affecting the fields of every particle in the universe, right, as we saw earlier. Are they affecting the gravitational waves by other black holes that are rolling around each other? Are we talking about a single space-time here? Are we talking about gazillions of space-times? They show this as a smooth, wave coming out of the merger of two black holes. Well, how about all the other black holes in the universe? Aren't they sending gravitational waves that interfere with these waves if it's a single space-time? Okay, so yeah, we have a problem with this because this is too neat for explaining anything. How they could measure this without the interference of so many other waves coming from every place in the universe is a mystery to this day. Okay, nobody can explain that. Okay, then they have this other explanation, can we call it? The multiverse, okay? And I like it because they show it with stars in the background. Sometimes they show it in different ways, but this is one version of that. And so we have all these universes, and one of them is ours, right? And the question is, what's the blue stuff that separates one universe from another? That's what I want to know, because each universe, all that black stuff that you see there, that's space. Okay, so they have these balls of space with matter and time and who knows what else inside it, light, inside the ball. And what's the blue stuff? That's what we want to know. What's the blue stuff that gives shape or contrast to each one of these balls? And of course, it can't be space because space is inside each ball. And if it were space, then there wouldn't be any balls there at all. It'd all be a single, just a bunch of matter, and there would be no many universes, multiverses. So yeah, this is irrational, totally irrational, garbage, nonsense. And again, they have God's ear and they can tell you what God is saying, telling them how the universe works. Here we have another fellow. His name is Brian Greene. Some of you know him. And he's going to go out there and do some time travel. Time travel? What do you mean time travel? He's going to travel through time. You can travel through water, like in an ocean and a lake. You can travel through air, it's a medium. Can you travel through time? Is time a medium? Can you cut across time? What do you mean travel through time? But that's one issue. The other issue is that he says that he can go out there to a black hole, come back close to the speed of light, and it's this famous twin paradox. Well, everybody on Earth aged, many years, maybe 40, 50 years. He only aged about 2 hours. That's what he's saying. Does that make any sense? Well, listen to him so that you don't say that I put words in his mouth. Here it is.
One way to travel through time is to make use of a strange feature of gravity. Like...
See you later, sir.
Right. Much later. So, how can gravity be used to make a time machine? Well, depending on the black hole size and how close I get, a if I spend an hour or two in orbit, something like 50 years will have passed back on Earth. I will have traveled to Earth's future.
Well, yeah, I think he was in orbit. I'd like to have whatever he had, maybe for him it was only 2 hours, but yeah, that's what these people say, that, for them it went 2 hours because they traveled at close to the speed of light, came back, and for everybody on Earth, everything went, time went by a lot faster. And yeah, there's obviously nonsense. It's poppycock. Has nothing to do with rationality. First of all, because, the Earth, if we count years, the Earth revolution around the sun, that's 1 year. And whether he went out and came back and counted something else with his atomic clock, we don't care. When he comes back, he better have the same number of revolutions around the sun as we did here on Earth, because there's so many revolutions of the Earth, and it does it only once. It can't do a different number of revolutions for him because he traveled than it did for us. Okay, the Earth went around the sun so many times, whether 20 times, 30 times, 40 times, for everybody in the universe. Okay, that's one issue. More important issue is the universal movie. Okay, and the universal movie destroys special relativity completely because we clean our nose holes, with time. There is no such thing as time, and so let's show that, okay? Here we have the universal movie. What is that? Well, the universal movie says that there's a single frame in the universe. We take a picture of every atom in the universe, everything in existence. I don't care how far it is. We use God's camera, three-dimensional camera, and we take a picture of everything. And that's a single frame in the movie. In the next frame, every one of those same atoms moved to a different location, okay? So it's no longer at the previous location, it's now at a new location. We did not create every atom all over again at a new location. We don't create, in every frame of the universal movie, we don't create every atom all over again, clone them, and say, now this atom has been cloned at a new location. So the previous atom, the one that was at a different location, is the same atom that's now at this new location. And the previous atom no longer exists in that sense. It's no longer there. So, Father Universe, he doesn't keep track of where the atoms were before. He doesn't have a filing cabinet. So here you can see that's all there is. A single frame at any point in time in the universe, or a cross-section of time, or a cross-section of motion. Okay, so every atom in the universe only exists once. We talk about existence, not about motion. Okay, and yeah, so if you look at God, good old God up there, he doesn't have a computer or a filing cabinet where he keeps, all the actions by every atom that existed in the past. It's not like he's got a filing cabinet there and that he goes out there and keeps track of. He doesn't have a computer where he has all these angels bringing him information or whatever. Okay, so all this nonsense about time travel and being able to land where the atom was millions of years ago or hundreds of years ago, that's what's nonsense. Okay, yeah. So all I can tell you is time is something that humans invented. Father Universe does not recognize time. Father Universe only is made of atoms, and all atoms have a single location, a static concept, certain distance from all others, and in the next frame, every atom moves to a new location. That's all there is. And, you can't go back to the frame of the film in the Universal movie 100, 200 years ago and expect to find an atom there the way the universe was 200 years ago and land, maybe, I don't know, to see Napoleon or whatever, shake hands with him. You can't do that. You can't do that because Napoleon, the atoms of Napoleon are today somewhere else, okay? They moved. That's all happened. And that frame of the film no longer exists. There's nothing there. So you can't go back to there and say, I'm going to find some Earth that existed 200 years ago with all the atoms, just like it is today. The same atoms at a different location. Then you would have atoms at two locations like quantum says, which is totally irrational, because that would mean that instead of moving, atoms are being cloned at every location. That's what they're saying, essentially. So yeah, there is no such thing as time. We don't use time in science. Time is a mathematical construct. It's great for measuring things here on Earth, but it's got nothing to do with what Father Universe is. Father Universe is just atoms. That's it. Every atom at a given location with respect to all others. That's all it is. Okay, so then we have this other nonsense that's popular lately. It's called dark energy. Aside from dark matter and black holes, we have dark energy. What is dark energy? Well, let's find out. Let these people tell you in their own words what dark energy is. They're studying it every day. So here it goes, okay? Listen carefully.
Dark energy is one of the biggest mysteries in physics. It dominates the universe, making up 68% of its contents and pushing matter apart with its repulsive force. The simplest explanation for this acceleration is Einstein's cosmological constant, an unchanging dark energy that permeates empty space.
The universe is expanding. We're essentially getting more and more empty space between galaxies and consequently more and more dark energy. We often say dark energy because cosmologists are kind of in the dark. We really don't know what it is.
So what is dark energy? Well, they don't know, but they needed this fudge factor in order for their equations to come out right and to explain what they observe up there, but they had to make it invisible. Everything's dark in mathematical physics. You know, they have dark energy, black holes, dark matter, everything's dark and black and nebulous, right? They had to make it like that, and then they asked the astronomers go look for it. Okay? Yeah, so they've invented all these concepts, these nonsensical explanations, because they have no way of explaining how this universe works. They have no idea, either at the quantum level, the micro level, or at the macro level, the universe, the cosmic level. Either one. Okay, and finally we have this other issue, which is known as the Big Bang, the origin of our universe. It looks something like this. Okay, they have all this explosion going on that turns into this can or glass that's lying down. Okay, we're at the present, which is the rim of this glass. Okay, there's this explosion that happened apparently 14 billion years ago. And of course, the only question they cannot answer is frame number one. What happened on day one or minute one or second one? You know, how did this, where did this explosion come from? You know, the first bit of whatever, they call it a singularity. Where did that singularity come from? And they say, well, that's a philosophical question. No kidding. Yeah, that's the only question they had to answer. And then the other issue is, you know, what's the black stuff that surrounds the glass there, or all these, all this, because what you have the expansion of space. And so what's surrounding space? What's outside of space? And sometimes they say, well, space is infinite, and so there's nothing outside of it. And so they have all these different explanations to try to weasel out of them. When they can't answer no more, well, they say, well, go ask the philosopher. We can't answer that question. Father Universe doesn't speak our language. Okay, that'll solve it, everything. And so one fellow says, you know, and this is what a lot of people say out there, that we'll never understand the universe. We shouldn't even try, because all we can do is model some things and measure and so on, but we'll never be able to answer questions like why, you know, explanations, causes, mechanisms. We'll never be able to answer that. And here it is. This fellow says, science will never be able to explain the reasons why the universe is the way it is, because it doesn't have such thing as reasons. Well, in that sense, he's right. Reason has to do with God making something. Then you could say, why did God do this? Well, he had a headache. That's why he did it this way. That's a reason, a purpose. But the universe has no purpose. What we're talking about is something different. We're trying to explain not the reasons, we're trying to explain the causes. And people confuse causes with reasons constantly. They confuse purposes with mechanisms. Everything we as humans think we know about the universe is only a poor attempt to understand the way it works. Yeah, the way it works is different than reason, but we'll never get to know what is the actual explanation behind it. Why does he say we'll never be able to explain it? He thinks it's beyond hope, and all people really think like this fellow out there. A lot of people think like this individual. The theory of everything is supposed to fully explain and link together all physical aspects of the universe. But I think the actual theory of everything is that the universe doesn't need to possess an explanation at all. And again, he confuses, reasons with causes. And it also shouldn't make sense. Why shouldn't it make sense? But this is when a lot of people conclude like this. They've given up and they say, I don't care about all that because I can't make any sense of it. And none of these mathematicians who call themselves mathematical physicists, they can't explain it either. So they've given up hope. Since those are the only ideas created by human mind trying to find patterns in stuff. Any attempt on understanding the universe, existence, reality, and what comes with it is going to result as futile and is going to be limited by our own capacity to understand what we observe. Okay, so a lot of people have given up hope, and they say, there's no way we can explain how this universe works, why it works, how. Not meaning I can measure and I can describe. That's different. We can describe that the Earth goes around the sun 365 days. We invent some standards and we can deal with that. That's different than asking why, meaning cause, right? Does the Earth go around the sun and doesn't fly out of the solar system? That's a different question. Okay, and that's a question of physics. And that's a question that they can't answer, even to this day. Okay, so let's summarize. Here's the explanations. The mathematicians, who are the priests today, these are the explanations they give us for these phenomena. In quantum, particles at two places or in two states, faster than light tachyons, they come from the future. They destroy special relativity. They don't care. They talk about tachyons every day. And so it's like, did you hear that in special relativity, it comes all the way to 1908, special relativity says that, the speed of light is, fixed. And it's like they say, well, we've been wrong before, so we're going to introduce faster than light travel anyways, against all odds, against all measurement. They don't care. They just fit it in there and they get away with it. They just say whatever they want. Electron doesn't fall into the nucleus. It doesn't fly away. Virtual particles coming out of nowhere, just a fudge factor that they need for their equations to come out right. Wave function collapse turns into a ball. Entanglement, no mediator. This particle affects that one, again, by remote control, the voodoo doll, right? Fields morphs into a particle, a little peninsula that comes out of the field. How that one can travel, I don't know, because it's got its butt tied to the field. The only way it could get its independence if it comes completely out of the field. But they say, no, a particle is the vibration of the field, local vibration. Yeah, that doesn't explain how these particles can fly individually, independently, discretely from here to there. So, yeah, they replace quantum with a field. The field is an extended type thing, and that's what they're trying to reconcile with general relativity, because relativity is a field theory. They say, hey, if we make quantum into a field theory, we can probably merge them both. Yeah, but that destroys the quantum, because quantum is a discrete, not an extended thing like a field. And that's why they like the field, because it has the best of both worlds. Again, all these paradoxes that they never resolve. The discrete with the continuous or the extended, right? They like both properties. They cover all the bases, so to speak. It's all of the above, and that's the problem. The problem is that they're using the field because that's very handy to merge it with relativity, at least mathematically. But at the same time, the explanation is that a particle is a vibration of a field, and the particle stuck to the field. It's not an island, it's a peninsula. It's a protrusion of the field. It's got no independence. And that destroys, any notion they could have from quantum mechanics. If they go with that, quantum is dead. And it's been dead for a while now. Then they have the gluon springs, the ones that, accordions that keep the quarks together, and a gluon quark soup. Yeah, again, all done with magic. All of it is magic. Not one of these explanations is rational. Not one of them has any place in science, in physics. And so the explanations are all dead from quantum mechanics. Quantum mechanics, for the last 100 years, we've had nonsense only from quantum mechanics. And just in case, we also have had the priests tell us about relativity. And what does relativity says? Well, they have gravity as warp number lines, especially the number line called time. Now, that's a number line that's very hard to bend, Try to bend time. Never tried it, but must be very scary stuff. Gravity waves go through gravity waves. You have all this interference from all the gravity waves in the universe. Okay, we have all these fields, right? They're all vibrating. You have the muon field, the graviton field, the Higgs field, all these fields, and they're all, going right through each other. And nobody asks the question, how do they go through each other? Well, very simple. Nobody asks the question because a field is constant. See how easy it was? So nobody asks the question. It never even pops in their minds that they can ask such a question. Multiverse, many universes. What separates one universe from another? Someday we'll figure that out. Okay. All we know right now is that every universe has everything in it. It has space, time, matter, the whole works, light, whatever you want in there. And so, what separates it from another universe? That's the only question they have to answer. We need to know what's between these universes. That's the key question. Time dilation, total idiocy, that you can dilate time. And again, have especially the twin paradox, the fact that, you have different times for different people. One thing is what they measure. We don't care about that. We care about what is. And the Earth can only go around the sun, 365 days, and so many times, so many years, so many times means so many years. So we went around 20 times around the Earth. We don't care how far, how fast. The twin travel, when he comes back, he better count the same number of revolutions, okay? Mass increase, again, total nonsense, because they're talking about weight, how much this mass supposedly presses down on the scale. And the question there is also, is it being pushed or is it being pulled? See, when you put yourself on the scale, you're being pulled by the Earth, okay? And again, every atom in your body is tied to every atom on Earth. There's a pull there because there's an elongated object that we can't see or touch that binds, that connects every atom in your body to every atom on Earth. Very simple. So it goes right through the scale. Okay, so that's why you're, pushing down on the scale. But when they show the mass increase, they just show it sideways. And the question is it being pushed or is it being pulled? Why is the mass traveling close to the speed of light towards, whatever's going to measure its gravitational pull or its mass or whatever they want to measure? Okay, is it being pulled or pushed? That's the question. Okay, and then you have length contraction. Again, nonsense. They're talking about distance contraction because they're going to measure distance traveled. It's distance traveled contraction, not even length or distance. Okay, what they're saying is distance traveled contraction, contracted. Black hole, total nonsense. The little singularity. There's two types of singularities, two notions. And again, it's all of the above always. In one case, the object, usually it's a star, collapses totally, completely, okay, until there's no matter left. Okay, so it turns into a little point, little dot, not even a dot because a dot has 3D or 2D at least. This one is 0D. So it's a 0D dot, okay, 0D point. Okay, it's a location essentially. And this location has infinite mass because it's got no structure, no, all matter that went into the black hole was crushed out of existence. Okay, and the singularity has an effect on something far away. And the question is by what mechanism? And they say, well, it's mass. Yeah, but mass is not a mechanism. So that's where that one fails. But then you have the other notion that singularity is not really a dot, a little point where all the matter is concentrated there. The singularity is like a hole. We don't know what diameter that hole has. but everything is rushing towards the hole. Everything is falling into the hole, but never makes it there. That's the infinity where the laws of physics break down. Okay, that's the poppycock, the idiocy coming out of Cambridge and Harvard today. Okay, that's the idiocy these people believe in. This is what they, teach out there. This is what they claim to know directly from God or from Father Universe or Mother Nature or maybe the devil. I don't know. And they say they have a special ear because they know all this math, and they translate the math into an explanation. And you have to believe them because of that. When you say you don't understand them, they say, well, we don't all understand the ways of God. Or said in other words, God does not, the Father Universe does not always speak our language. He doesn't have to conform to our notions of how the universe should be. Well, the way we answer that is very simple. I don't care about Father Universe. I care about your explanation. If your explanation is irrational, I'm just going to take your irrational explanation. I'm not going to ask Father Universe, who told you that you represent the ways of God, the ways of Father Universe, right? Who says that you're his interpreter? Who says that you're his spokesperson? That's the issue. Okay? So who designated you as an angel that brings the message from heaven, right? That's the question. And we have obviously dark energy, dark matter, a fudge factor that they put to explain why a galaxy rotates like a carousel. The buggies on the outside at the same speed or faster than the horses on the inside, right? And they cannot explain that, so they had to put a fudge factor called mass. And that extra mass is what they call dark matter. It's an invisible stuff that they can't see that has lots of mass, the mass necessary for the equations to match what they observe out there. That's what it is. And now they ask the astronomers, go look for it. It's dark. And finally, Big Bang, the creationist society that the mathematicians have created. They say that the universe had an origin some 14 billion years ago or whatever. Started how? How did it self-start? And that's when the religious folk, the traditional religious folks say, well, we know who started it. It's this guy with a magic wand. His name is God, and he set it in motion. And these people say, no, we can do it without God. It just started by itself because we see it every day in the laboratory where we see the particles popping in from the void completely on their own. They just borrow energy for a little while, come into existence, and then go out of existence. And just like that, that's how the singularity, the original singularity came to be. It came in from who knows where, because the singularity includes space, time, and matter, so who knows what was outside of the singularity. Where did it come from? Well, it's, that's what you got to ask the philosophers. That's where their knowledge stops. And yeah, these are the irrational explanations that the mathematicians who preach today, the same thing that we preached thousands of years ago, where people believed in the only people who could read the Bible. Well, today people believe in these people, in these individuals who study math, and they say they can translate those equations into how our universe works, meaning why it works the way it works, the causes, the mechanisms. And when you question that, they say, well, God works in mysterious ways.